So guys, today we will discuss about derived carbohydrate. What are derived carbohydrates? The carbohydrates which are obtained through the oxidation, reduction, dehydration reaction are known as derived carbohydrates. Mostly these carbohydrates, derived carbohydrates, are derived from monosaccharide through oxidation, reduction, or some other process. So first of all, what are monosaccharides? Monosaccharides are the simplest sugar or compound which possess free aldehyde or ketone group with at least 2 or 3 hydroxyl. Or you can say they are the simplest sugar which cannot be hydrolyzed further into smaller units. Oxidation, what is oxidation? Loss of electron, loss of hydrogen and gain of oxygen is known as oxidation. And what is reduction? Gaining of electron, gaining of hydrogen and loss of oxygen is known as reduction. So the alcoholic hydroxyl group, which is present on the carbon number 6 of aldosic sugar or ketonic sugar, or aldehyde group, which is present at the first carbon of aldosic sugar, and ketone group, which is present on the second carbon of monosaccharide, are oxidized to carboxylic group with a certain oxidizing agent is known as oxidation of sugar. What is the reduction? It is vice versa. Aldehyde or keto group are reduced to hydroxyl group with certain reducing agent like sodium amalgam is known as reduction. The oxidation may be brought under mild or with vigorous oxidizing condition. With mild like bromine water, only a aldosic sugar is oxidized into ester. In this group, only aldehyde sugar is oxidized to produce gluconic acid or monocarbonic acid. Ketonic sugar or ketoses do not respond to this reaction. With strong oxidizing agent, all aldosic or ketonic sugar both are oxidized into dicarboxylic acid. Oxidation with basic condition like metal hydroxide, like copper hydroxide, silver hydroxide, oxide, oxidized pre-aldehyde or ketone group into acid of muto-rotating sugar and reduce themselves to oxidize of free metals. So metal get reduced but sugar get oxidized. Reduction. The aldehyde group or ketone group present on the monosaccharide can be reduced to its respective alcohol with sodium amalgam is known as reduction. For example, fructose is mostly changed into mannitol and glucose is changed into sorbitol after reduction. Then dehydration, which is present the monosaccharide when treated with concentrated sulfuric acid, it gets dehydrated to form 5-hydroxymethyl perfluoro derivative. Methylation or esterification, the glucosidic alcoholic group of monosaccharide and reducing disaccharide react with acetylating agent like acetic anhydride in pyridine environment to form acetate derivative are called ester. Mostly ester bonds are formed when the glucose, fructose or other monosaccharide react with the phosphate group or other groups. Minor sugars, the sugar which have minor group on the second carbon. In case of glucose, it is known as glucosamine. In case of lactose, it is known as lactosamine. And if an acetyl group is that like CH3C double bond O, this is known as n-acetylglucosamine and n-acetylgalactosamine. All these sugar are derived sugar because they are derived from other monosaccharides. So these sugar condensed with the acetate to form n-acetylglucosamine or lactosamine. They are the component of hydropolysaccharide or glycosaminoglycan or some sphingolipids. N-acetyl monosamine, it is a component of glycoprotein and ganglioside of cell membrane. A polymer of n-acetylglucosamine is present in the cell wall of fungi, which is a chitin. N-acetylgalactosamine is a component of chondroitin sulfate. Then sugar acid, which is the oxidation product of monosaccharide like If the oxidation of glucose takes place, it changes into gluconic acid or hydronic acid. It is either in the carbon number 1 or mostly in the carbon number 6 of the glucose. L-ascorbic acid is also sugar acid. Gluconic acid involved in the detoxification of bilirubin, which is very important, and other foreign compounds. Sugar alcohol are formed by the reduction of carbonyl group, mean aldehyde or ketone group of monosaccharide into alcohol. For example, if reduction of glucose takes place, it produces sorbitol, mannose produce mannitol, fructose produce sorbitol or mannitol, galactose produce galactitol, reduction of ribose produce ribitol, which is present in the vitamin B2. Then sugar ester hydroxyl groups of sugars can be esterified to form acetate, phosphate, and benzoate groups. So, for example, in glycolysis, glucose is phosphorylated on the carbon number 6 to form glucose 6 phosphate. This is ester bond, phosphoester bond. Then we have fructose. Fructose is phosphorylated in carbon number 1 and carbon number 6 to produce fructose 1,6 base phosphate. And later on it will produce energy. Glycoside, what are glycoside? When the carbohydrate portion is attached with the non-carbohydrate portion, it will produce glycoside. And this is mostly ester linkage. In naming of glycoside, the O suffix of the sugar name is replaced by O side and the alcohol group name is present first. Cardiac glycoside like digito means these include derivative of digitalis and strophanus such as euben. So digitonin is used to control your heartbeat. Streptomycin is used as antibiotic, and fluoridazine displays sodium from binding side of carrier protein and prevent the binding of sugar molecule and produce glucose. Then reducing and non-reducing sugar. Reducing sugar is that sugar which have free aldehyde or ketone group, which can oxidize or reduce. They are hemi-acetyl and hemi-ketal. They exhibit mutation. They form oxidation with phenyl hydrazine hydrochloride to form oxides with hydroxylamine. The glucose, fructose, lactose, maltose, cellulose, these are all sugar of reducing sugar. Then we have non-reducing sugar, which do not have a free aldehyde or ketone group, are known as non-reducing sugar. They are in the acetyl or ketone form, acetyl form or ketone form. They do not accept mutation because they do not have free anomeric carbon, do not form oxazone, do not form oxides. Example, sucrose, glycogen, inulin. These are not reducing sugar. That's all. If you like that video, please subscribe that channel. Thank you all.